Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 1 to sum, and I'll try to make this a little bit more beginner friendly because it is likely that a good percentage of you watching this video are just starting out on Leetcode. So yeah, let me help you start out your journey and provide you a good explanation for how to solve this problem. So the question is basically we are given an array of integers, numbers, right? So as an example, we have 2, 7, 11, 15, and we're also given a number target, right? So in this case, like target is 9, and we are going to return the indices of two numbers that add up to target. So indices are basically the indexes of the array. So the first element is index 0, the second element is index 1, and so on, right? So we have to return the indexes in a form of an array of the two elements that sum up to target, right? So in this case, we return 0 and 1 because if you notice, 2 plus 7 sum up to 9. And what are the indices of 2 and 7? It's 0 and 1, right? So that's why we return 9. And they say we can return the answer in any order, so it could either be 0, 1 or 1, 0. And just one more example for completeness sake, if we have this array 3 to 4 and our target is 6, in this case 2 plus 4 is equal to 6, and the indices of that are 1 and 2 respectively, so that's why we return 1, 2. And obviously we can assume that we have exactly one solution, so we don't really need to handle the case where we can't find this or there are more than one answers, right? So how do we go about solving this problem? So I've written the array again here just for example's sake. Now one way to solve this problem is, we take each element of the array and compare it to every other element until we find the sum that is equal to our target, right? So for example, first we take 2, and then we try 2 plus 7, and then we try 2 plus 11, and then we try 2 plus 15, and if we still don't find the sum, then we move on to the next one, and then we try 7 plus 11, 7 plus 15, right? And if we still don't find it, then we move on to the next one, and then we try 11 plus 15, right? So we don't need to try the ones previously because they would have been tried when we were running through those. So overall, what will be how many operations will we do in the worst case if we were to use this algorithm, right? So the first one will be compared to n minus 1 other elements, right? So it will be n minus 1 elements, to be compared for the first one. The second one will be compared to n minus 2 elements, right? So we'll try n minus 2 pairs, right? And so on until the last one is only compared to one element, right? So until 1. So this is the summation of 1 to n minus 1, which is just equal to n times n minus 1 over 2. And this basically is going to be like n squared over 2 minus 1 half. So this is the number of operations we'll end up doing in the worst case, right? So it's n squared over 2 minus 1 half. And in terms of order, it's an n squared algorithm, right? So it's a big O of n squared algorithm because as our n increases, the number of operations will increase as a square proportion to the n, right? So this is a kind of good initial solution that will get us the correct answer because we'll keep comparing all the possible pairs, and as soon as we get a target of like our whatever target t is, we'll just return those indices, right? But the question is, can we do better? Like, how can we optimize this solution? So to optimize the solution, like, let's say when we're taking the first element, let's say number 2, we already know the target, right? So we know that we're looking for some number x which will equal to the target. So let's say the target is t, right? So there's only really one number here because if you solve for x, that will be t minus 2, right? So there's only really one number that will satisfy the value of x that we should look for in the entire array, right? So which is going to be t minus 2, or t minus the whatever element we're comparing, right? So really the question we need to ask is, is there an x in the array, right? So is x present in the array? And if yes, what is the index of x, right? So what kind of data structure allows us to do this in efficiently, right? So if we have a data structure where we have a map, a hash map, right? So if we have a hash map of the number n to the index, right? Then we can create a hash map of this array. So we can say like 2, is the key, and the index is the value is going to be 0. 7 is the key, the value is 1. 11 is the key, the value is 2. And 15 is the key, the value is 3. So now, once we have this hash map, this is just going to be, we can create this hash map in on time, right? Because we just need to iterate through the array once to be able to create this hash map, right? And once we have this hash map, then we'll iterate through the array again. Okay, now for number 2, do I have already a t minus 2 in the array? And then we'll find, for example, if t was 9, we'll find, oh yes, we have 7 in index 1, so we just return that, right? And looking up something in the hash map is O1 because it's a hashed data structure, so it allows us to efficiently look up each element. So now we'll be doing n operations to populate the hash map, and then another n operations going through each of these and finding t minus that x, whatever that x is at each index in the hash map, right? Which is another n operations. So it's going to be 2 n operations, and that is or just an order of n algorithm, which is much better than our previous n squared algorithm, because this algorithm just grows linearly as n increases, versus the other one would grow by like a square proportion as n increases. So now let's go ahead and just code this solution. So we'll start out with our map of integer to integer, which will be our element to index, right? This is the map we said we'd create first. And we'll just go through each element in the nums array. So we'll say, well, I equals 0, I less than lums dot length, I plus plus. So this will create a loop from 0 to the last index of nums. And here we'll just say lm to index dot put the element. So the key will be our element, which will be nums at I, and this should be nums. So it will be nums at I, the element, and then the index, which is just I, right? So this would populate our hash map for all of the elements. And then what we need to do is just again go through the nums. So we'll just again iterate through the nums. And now, our x, which is basically what we need to look for, is going to be target minus n, right? So whatever n we're at, we should look for target minus n. And then, if our lm to index dot contains x, so that means if we have x in the hash map, then we should get the index of x. So we'll say index of x is equal to lm to index dot get x, and our current index will be the index of n. So we actually need to create a index-based loop here. So we have an index-based loop here, and our x will be target minus nums at I, right? Because that's our number at this element. And then here the index of I is going to be just I, so we'll just return here new int I comma index of x. That means we have found our pair, right? And at the end, if we aren't able to find anything, we'll just return an empty array, but we are pretty much guaranteed here that we won't reach this case because they guarantee exactly one solution. So hopefully we'll be able to return something. We won't run into the case where we end up here. So Let's run this solution, see if it works, and then we'll do one more optimization before we close the video. So we actually have an error here because, in this case, we have 3 is in our map, and then we saw 6 as the target, but then, 3 and 3 add up to 6, but you can't actually use the same element twice. So yeah, this was actually the optimization I was going to do, but turns out that we need to do that optimization. So what we'll do is we'll keep populating our map, and instead of doing this logic over here, we'll just move this into the upper loop, right? So before we insert it into the map, we'll put this logic here. So basically we'll say, okay, this is our x which we're looking for. Have we seen this before, right? So have we seen target minus nums at I before, right? So if we have seen it before, we get the index and return it. Otherwise, if we haven't seen it before, we insert it in the map so that something in the future can use it. So this will guarantee that, we don't use the same number twice, because we aren't putting it in the map until and unless we have checked if a previous one is matching, right? And we don't return, and only then do we return if a previous one is matching. So the current one won't be considered twice. So now let's run the code. Hopefully this works. All right, this passes all the test cases, and let's submit. Perfect. So this is an accepted solution. Thank you so much for watching. I'll see you in the next video. Cheers.